Today, we're introducing you to Roger Vanderlee, CEO of HYDI, the Australian-made hydrogen product. Roger, we are hearing a lot about hydrogen. What is its relevance to our heavy transport?
The relevance is it offers the opportunity to have a very clean, very powerful fuel source, and we've invented a technology that can supplement diesel fuel to preserve the use of your diesel-powered assets in a very economical way in the long term.
Why hydrogen?
Hydrogen is a very powerful fuel and it's very clean. It has 3 times the calorific value of diesel, which provides for great efficiency.
What is HYDI?
HYDI is a hydrogen on-demand system that operates in a solo situation, retrofitted to an existing diesel engine, and it's totally self-sufficient.
How does it work?
The system takes a low amount of electricity from the battery of the host engine, and that electricity is amplified within the power module in the unit, which is part of our IP. It is then applied to distilled water through a proton exchange membrane cell to split the hydrogen and the oxygen from the water, and then that hydrogen is fed into the engine via the air intake pre-turbo.
What makes HYDI unique?
HYDI is unique because it uses no chemicals. It's distilled water only within this unit, and that's the only consumable other than the electrical energy that goes into it. It's very compact, 25 kilos, 640 millimetres long by 250 by 200. Comes in a couple of different configurations, so it can be packaged into any application certainly that we've come across to date, and there's quite a variety of them. It's very efficient. I mentioned that the electrical energy that it draws is minimal, and we are able to amplify the electrical energy to get the electrolysis process working efficiently. It's controllable via an independent app, and we can control the amount of hydrogen that this produces, and it can be load responsive in communication with the electronics of the host engine. And it's minimal intrusion into the actual engine and the equipment that it's fitted to, so that it's not a case of having to make major mechanical changes to the host equipment to get the benefits of the hydrogen.
Is it approved?
The unit is VSB6, that's Vehicle Standards Bulletin 6 approved for fitment to heavy transport, including those carrying packages.
And Roger, tell me what the benefits are of HYDI.
The primary benefit from a commercial viewpoint is the fuel saving. The other primary benefit, and was the basis really for the invention of the unit, was to take the emissions out of diesel. We are able to achieve a 56 to up to 80% reduction in particulate matter, and also reductions in other greenhouse gas emissions. It enables the engine to run much cleaner because you get a more complete combustion with the hydrogen in that process. A lot of the unburned fuel that is passed out through the exhaust system as particulate matter or other gases actually gets burnt. That provides a more powerful ignition within the motor, which in turn gives you a better power response and a smoother operation without having any impact on exhaust gas temperatures or engine coolant temperatures. So it's essentially load responsive. We can deliver an amount of hydrogen to optimise the performance of the engine based on the sophistication within the unit.
You mentioned a drop in particulate matter of 80%, Roger. How was this achieved?
This was achieved with independent testing with the University of South Australia under academic and laboratory conditions. The test equipment in that case was a 100 kVA generator.
Where and how is it fitted?
The unit can be packaged within the engine bay or in a related area. For instance, on a Metropolitan bus in Adelaide, we were able to put it in the engine compartment. On most heavy transport vehicles, we've mounted it on the rear of the cab or on the chassis immediately adjacent to the engine behind the the cab. And on a generator, obviously, it's a much more flexible situation depending on the nature of the generator itself.
How long does it take to fit, and is it transferable?
Yes, the unit is transferable, provided it's within the range of the unit in terms of engine displacement. So these units are applicable to engine sizes from 12 to 20 litres, for instance, and there are other models which accommodate different sized engines. It takes about 3 to 4 hours to fit it if we have the bracket available for that particular application. So the brackets are custom made to suit each individual fitment.
And Roger, where is the product manufactured and where was it engineered?
The unit is fully engineered and manufactured in Australia, currently between Western Australia and South Australia, but we are committed to maintaining an Australian manufacture, and 90% or more of the parts of this product are all manufactured in Australia.
And tell me, what happens if the unit stops working?
If the unit stops working, you unfortunately lose the benefits of having the hydrogen, delivering a fuel saving, cutting your emissions and getting better power and performance. But the engine will continue to run as it would normally run, and there's no impact on the reliability or the continuation of the motor.
And what are the consumables and rate of use?
The only consumable, other than the small amount of electrical energy required, is distilled water. On a typical heavy transport application, a 15 litre engine, the unit consumes 1 litre of water per 35 hours. The unit has a 2.5 litre tank, so this unit will run for about 80 hours before it needs a top up. And if it's used in an application where it's not getting or not wanting to have any intention long term, we can fit a header tank of 5, 10 or 20 litres, which extends the period that the unit can be operating on its own.
What are the servicing requirements?
Every 6 months we recommend, or we want a filter within the unit to be replaced, and that's an insurance policy in terms of protecting the PEM cell from any foreign materials. And at 12 months we would replace a small water pump which circulates the water within the unit. Both of them are very low cost items.
Roger, has it been rolled out in Australia, and for what other applications?
Yes, it has been rolled out in Australia. We've got units on trucks in Queensland, South Australia and Western Australia, and various different applications, from road trains to garbage trucks. We've had our unit on a metropolitan passenger bus in Adelaide with excellent results. We've also got a unit fitted in a marine application where we've got that particular application has 2 engines side by side. One of those is fitted with a HYDI unit and the other is not, for the purposes of comparing the results. With individual fuel tanks, the manual measurements have confirmed a fuel saving in the order of 12%. So that's a very good indication where we've got constant load, same conditions, same engines operating with the same equipment, direct back-to-back comparison.
And what is the return on investment?
The return on the investment obviously depends on what the individual costs are for the organisation. But by way of example, if you were paying $1 per litre for your diesel, and the information that we've gleaned from experience in the field, a fuel saving of 9 to 12% will give you a return on investment or a payback of 230 to 240 kilometres. Beyond that, you get the benefit from a profit perspective of the savings, and the unit's essentially paid for itself. And on top of that, there's other benefits associated with a cleaner engine, perhaps less servicing, better performance, better productivity.
And I believe there is an eligibility for carbon tax or carbon credits.
Yes, for a large fleet user, there is an opportunity under the Emissions Reduction Fund to register for carbon credits, which at 2.68 kilos per litre of diesel, if you're a large user or a large fleet, then you can accumulate a large enough saving, then you could be part of that program where you're earning $12 to $16 per tonne for a carbon credit.
Okay, very good, Roger. Now, we'll demonstrate that, if you could demonstrate the product and how much gas is actually.
So the gas is actually fed into the air intake via a line pre-turbo. So the turbo draws the hydrogen in with the air intake of the engine. And here's an example of hydrogen being produced at the current setting on this unit. So this is installed according to our instructions in a fully sheathed fireproof line, and all the settings within the unit are very safety conscious in terms of multiple fuses for feeding, and the default position for any irregularity with the unit is that it switches off.
And tell me, when we require more water, what is telling us where we need to refill?
There's a number of lights on the front of the unit, and when the refill light comes on, you're down to about half a litre of water. So based on the time that I gave you earlier, you've still got 10, 15 hours of running. It's a matter of putting some distilled water back into the tank via the filler tube, and that can be facilitated by a driver having a 5 litre container of distilled water in his cabin toolbox.
Well, Roger, winding up, thank you very much. Where can we find more information about HYDI?
If you go to www.hydi.com.au, there's more information available on our website. Well, we'd be very, very pleased to hear from you. And we encourage you to be part of the net zero carbon objectives, not just in Australia, but in the world. Particulate matter in the world, according to the World Health Organisation, has a significant impact on people's health to the tune of 7 million deaths per year. And given that there's about 95,000 articulated vehicles in Australia, according to the 2016 census, we can save 10% of fuel, and we can save a lot of carbon emissions on top of that, then that's got to be a good thing, both financially for you as an organisation, from a profit situation, and from a community and corporate perspective, to be a responsible corporate citizen in terms of climate change contribution.
And again, the web address?
www.hydi.com.au. We look forward to hearing from you.
Thank you, Roger.